Now let's initialize the model and change it to a dynamic model, shall we? Okay, so let's go to Eng-Man here, and you will see what happened after we initialize the model. Okay, so initialize dynamic model. You must save project before continuing. Save project. All right, and let's wait for a while. Create result. Okay, let's call it result1 for simplicity. Still initializing. All right, so after initialization, this is what happened. You see, we only focus or we only honor the grid blocks that are active. All the grid blocks with Eng-Man of 0 are deactivated and will be neglected. Now we are in, so the software will produce a new set of grids, set of 3D grids. Now it's called dynamic model inside the parentheses here, okay? As opposed to this one without dynamic model. So this is the static model. If you want to rename it, you can. So just to make a distinction, so this is the static model. That's why you can see all the grid blocks. You see, so we still have our static model, but you can also switch to the dynamic model. Boom. Okay, so you only focus on this one. Here we have all the dynamic properties. The initial and then the calculated. All right, so now after you put all the grid blocks and fluid properties parameters like relative permeability, equilibrium, and so on and so forth, now you get these calculated results like the pressure, saturation of oil, saturation of water, and so on and so forth. Okay, and later, after we run the model, after we perform the simulation, all here in this, the fourth grid blocks here called results will be relevant. You can capture the results here. Okay, but currently after initialization, this is our grid blocks. This is our 3D grids. Okay, so now is the time to, maybe you can show you the fluid in place here, oil in place. Okay, just for starter. All right, now is the time for us to run the model. Before that, let's go to case. We only have one case. This is just a template. Okay, so you can neglect this. The dynamic model, this is just a starter. It's not meaningful for us. But what's important is here, this is our first case called black oil demo. So if you run the model, you get the results. It will be the result of this case, black oil demo. Okay, so you can also expand and the result will be stored here. Okay, so I will click on run and calculating. And then we go to graphs. You can uncheck the group production table and choose the model, which is black oil demo, expand, and then check this one. The results will be shown by this, the results. And let's select, for example, basic templates, history matching total oil field. Okay, and then go to groups, field, and then there you go. You have here the liquid simulated or his calculated result and the history, and then this oil total, water total, pressure, water injection, and water cut. So that's the basic template. Okay, sorry for the background voice. Right, so we are reviewing, we are observing the result here. And later I will create another case and compare what happened with this case. right? I'm going to mute myself for a while as we as we observe the progression of the simulation, okay? Okay, so now we are reaching 32% of the progress. Okay, I'm going to pause the recording. Okay, so see you later. Okay, so we get the first result from the first case. So we achieve perfect, perfect matching for the liquid, but not so good for the oil, not so good for the water. Okay, pressure will be calculated. I don't think we have the data for pressure. Water injection, okay, quite good, but water cut, not so good. Okay, so this is the first case. You see, we have high water production compared to the actual. Okay, so because we have high water production, that's why oil production is below the historical. Okay, so what should I do? I'm going to modify the relative permeability. Okay, so what next is we go to cases here.